Hi, everyone. My name is Allie Cooper. I'm an undergraduate student at the University of Washington, majoring in environmental science. And I'm going to be presenting on using Lidar to identify red alders, specifically in the Sappho long-term ecosystem productivity experiment. So before I dig into the background, I wanted to go over the project objectives. Step one of this project is to line up Lidar data with existing field data on tree species locations within the long-term ecosystem productivity experiment. Then step two is to use that information and the information on which Lidar point returns correspond to which species to make a training data set. And then step three is to ultimately use that training data set to create a model that then can identify red alders. And the reason why we're looking at red alders specifically is for PhD student Courtney Bobson, who you may or may not have heard already present today. And one of the things she's looking at for his thesis is the impact of red alder on understory plots within this long-term ecosystem productivity experiment. And so far for this project, we have step 1 and 2 in progress. And step 3, we have preliminary results on the model, but nothing final yet. So a little bit of background into the long-term ecosystem productivity experiment located in Sappho, Washington, established 1995. And here's a map of the different plots. These big yellow rectangles are different blocks, and the smaller red squares are individual tree plots. And the goal of LTAP is to study the impact of management practices on long-term ecosystem productivity by basically mimicking different stages of forest development and doing this by several different manipulated variables, such as thinning, what tree species are replanted after the harvest, and how much down wood was left behind after the harvest. And me and several other interns this past summer of 2020 went in, and for a bunch of tree plots, we collected azimuth and distance for the trees within the plot. From this, we were able to make STEM maps, basically maps showing spatially for each tree plot where the species within the tree plots were in relation to each other. And we also took information too for each of the trees, such as DBH and tree species. And this is actually a picture of me in the summer measuring distance for one of the trees. Then on Lidar data, it's winter 2015 Lidar data downloaded from the DNR Lidar portal. Basically, when we download this, it comes as a point cloud. And this is a side view of a point cloud. And you can kind of already see the different trees here. And then we're able to use that point cloud to make a canopy height model, which is what this is. And you can kind of make out the canopies of individual trees. And those also show us the height of the trees. And so what we did is combine the field STEM maps from that field data with the canopy Lidar models. So basically, we knew vaguely where each plot was, but we had to line up each trees with the corresponding canopy from the Lidar. And I'll zoom in on this a little bit. And each polygon, the color of the hand-drawn polygon represents the different tree species. So for instance, for like this tree 3, because we know from the field that this is definitely a red alder, because that was information that we took, we can then say, okay, knowing now that this is the location of that tree, that all of the Lidar return pulses within this area belong to red alder. And we can say that for basically all the trees and all the tree plots, and then get point returns for different species and have that information to create a model that we can then apply to a larger area and say, okay, knowing that this is what the point returns for like red alder look like, we can find those similar returns within a larger area. And like I mentioned before, the results on final, this is an in-progress project, but preliminary results show significant difference between red alder and other tree species using several Lidar metrics, which is super awesome. And I want to say a huge thank you to my team, Kevin, Courtney, Bernard, Sarah, and Bob. And a huge thank you for all of you for listening.